Alright, we're going to complete the following synthesis, and I have butanol there, and I want to turn it into butanoic acid. Alright, that's just oxidization of an alcohol. Plenty of ways that we saw how to do this. Probably the first was with some either chromic acid or sodium chromate with acid, and that's what I'm going to put down here. Previous problem on this, I actually talked about using some of the sodium hypochlorite, but I'm going to do chromic acid on this because that will definitely do the same thing. But that turns any primary alcohol into a carboxylic acid, and that's all I have to do in this case. Alright, number 19, complete the following synthesis. Alright, I have an alkane, so without even really looking at any other thought processes, I know I'm going to have to halogenate that. And the biggest reason I know that is that's the only thing we can do to alkanes at this point. And I did choose bromine because I don't like multiple products, and chlorine would have given me the terminal locations as well as that secondary one. And yeah, this will work. Alright, so I have a bromine on there. What I'm going to do is turn that into a carbon that is an oxygen and OH. And I just need to kind of, something we introduce in this chapter, attack that with some cyanide and get a C triple bond in there. And the reason I like that is because technically a nitrile is a carboxylic acid derivative. And I can do this in one step with a little bit of water and some acid and some heat. That'll turn any nitrile into a carboxylic acid, where the carbon of the nitrile is the carbonyl. Alright, so that step there is from chapter, is it 10? I think it's chapter 10. No, it's not chapter 10. Chapter 10 was alcohols. So that must have been chapter 12, where we did our free radical halogenation. If you remember, where was that wonderful chart? Our chlorines were selective. They liked tertiary and secondary more than primary, but we always ended up with mixtures because those numbers were close. But in this case I used bromine because bromine is very selective on where it goes. So in this case I would have got a really high yield of this. And the biggest reason I needed to do that first, without even looking at what the final product is because I have an alkane, and halogenation is the only thing we can do to alkanes. Once it was halogenated, then I started to figure out how to turn that new product, this guy, into what we wanted. Alright, question 20. Starting with methyl ethanoate. Ethanoate with a methyl on it. Synthesize ethyl ethanoate. Alright, that's easy enough. We're actually just replacing that CH3 with the CH2CH3. And this is just going to be transesterification. This guy's going to replace that. Now that is coming out of our latest chapter here, 15. Transesterification. We react an ester with an OH and we get that replacement. And it did say using a neutral reagent, so we have to have an OH on there. Now we could do it either case, right? If we do it under basic conditions, we can actually make it a nice one-way reaction. So what I was going to do is, here on my arrow, I'm going to have an O negative CH2CH3. So this deprotonated version of the alcohol we want to attach, we have some of that in there, and that'll pop that right on there, and we will produce, if you go back there, Also a little bit of ROH, which is technically that R. So we're in this case going to make a little bit of CH3OH. But using that OCH2CH3 should make this a nice one-way reaction where all of our ester is turned into the ester we desire, in this case the ethyl ethanoate. Had we used just ethanol with an acid catalyst, they'd exist in equilibrium, and it's hard to predict which ester is going to be preferred, but you will pretty much always end up with a mixture